and your story, how you started up in data science, I guess, and then we can go into a bit of some demonstrations, I guess.
Hmm. For sure. And someone had their hand up there before. I don't know if it got solved or not.
Yes, I had one question. I don't see the messaging option here. I'm kind of sick now with COVID, so I don't want to talk too much, but I have some questions. Is it possible? If not, I talk. That's not a big deal.
Sure. I'll add you to the team here, and you'll be able to chat. For anyone else, you can go ahead and use the chat to ask questions, get those queued up. Alrighty, we can. I guess we can go ahead and get this party started.
Yeah, perfect. You want me to I'll just introduce myself then, and then yeah, okay, perfect. Yeah, so yeah, thanks for everyone for joining this chat. My name's Matt Cook. I'm a senior data scientist for the Government of Manitoba. I got into data science sort of a roundabout way. I don't have as direct path into the field as probably a lot of you either have or are hoping to get. I'm assuming most of you are sort of in the data science and machine learning program. So my background is in psychology. So I'm currently finishing up my PhD in psychology right now in the brain and cognitive sciences area at the U of M. And it's sort of a strange area of psychology I'm in. So I'm not, the type of psychology you might imagine of, a therapist helping people, with mental health issues or that sort of thing. The area of psychology I'm from is really an experimental research branch of psychology. So studying things like memory and perception and language, things, how people perceive the world and remember and make decisions and know things, so that sort of thing. And as I sort of went along in my background, I sort of became more interested in programming and in statistics, and then got more interested in the machine learning side of things. So by the time I sort of got to my end of my degree, or I'm very close to that now, I sort of realized what I was really interested in, whether I knew it or not, was data science this whole time, even though I wasn't really thinking of it in those terms or with that particular phrase. But I really became interested in research and statistics and the technical methods that all of you are interested in as well. So, I mean, I have a couple pieces of advice that I maybe will just mention that I was trying to think what might be useful for all of you, whether you're mainly interested in data science or some sort of related field. I was trying to think back to what I would have maybe liked to have known, a few years ago when I was, I guess you never finish trying to figure things out, but when I was really trying to figure things out, some of the things that I would recommend to you is to think about, very early on, start thinking about what your strengths and your weaknesses are relative to, other people in your same program, but as well as other programs that are related. So what I mean by this is, for me, as I was going through my PhD, I thought, okay, I'm going to start applying to jobs soon. What sort of skills or, techniques or methods or tools do I have that other people don't, right? And when you start to look around the other people and, in the same program as you sort of realize you have a lot of similar overlapping courses and experience and projects and that sort of thing. So you want to start to think about what you can do to differentiate yourself from the people in that program, right? Because when you go to apply at this job, a lot of the people, if they're from the same program as you, you're all going to kind of have similar experiences, right? And that's, I'm not saying that to cut it down. That's just how it works, right? We all go through these programs together. But you want to start thinking about, well, what things could I do to sort of build my knowledge base or my portfolio or, the skills that I have that will sort of differentiate me from other people within this program. And sort of similarly too, if you're going to apply to a data science job, right, it's not only going to be other students from Red River College applying, but it's going to be, computer science majors, right? So you want to think, well, how do I stack against a computer science major? And, I don't know as much computer science as a computer science major, but I have these other skills, right? Like I've studied more statistics than a computer science major, or I've studied, I have a little bit more machine learning experience than a computer science major, or this or that. So when you start thinking about, how maybe you stack up against these other people from different disciplines, it gives you some obvious routes to kind of investigate more, right? For me as a psychology student, I don't have as much background in computer science as a computer science major, so I sort of went out of my way to learn more about those things so that I'm not as good of a computer scientist as someone who's in computer science, but I can at least hold my own and kind of know what I'm looking at, and decent with programming and that sort of thing. And similarly, right, if you're up against someone who's from a very research intensive background, they're going to have half a dozen or a dozen professional projects that they can show that involve data analysis and statistics and that sort of thing. So you don't need as many as that, but you need to have some projects to show, right? And this kind of fits into when you're getting your portfolio together, you want to be able to, when you go into these data science interviews or whatever type of interview it is, software developer, whatever, you want to be able to convince those people that what it is that they want for this job, right? You're able to do those things because at the end of the day, they're really just looking for someone that can do the job. And if you have a set of projects that demonstrate that you know how to do this, the types of things they're interested in, it's very convincing as opposed to just saying, well, I attended a workshop or I did this or that. If you have this portfolio to show them, it's very convincing, and it's a good demonstration of your abilities. You're showing them that you know how to do these things rather than just telling them. So I could go on and on and on, but maybe that was one of the things I kind of wanted to mention. There's a couple other I'll kind of sprinkle through this, but yeah, feel free to ask questions. And as Justin mentioned, if you don't feel comfortable raising your hand and asking in front of everyone, you can just, I think you can type it in the chat. I don't know if I see the chat right now, actually, on mine. But maybe if someone types something, I'll be able to see it.
I can probably just moderate for you, Matthew. You just go that way.
Okay, I cannot see the chat neither.
Yeah, I don't see the chat, but yeah, if you can see the chat, Justin, and people can get messages to you, then
sure.
Yeah. And then there was one other kind of thought that I had that's sort of really important, and then maybe we could get into a bit of a demo in R or something like that, unless there's some questions that you want answered before that. But one of the big things that I sort of realized once I got this job and started talking to other people with similar roles is just how different data science roles can be. So we think of like data science as like one thing, but the range of experiences you can have, or the range of data you can be working with, or the range of methods that you can be working with day to day as a data scientist can really differ a lot, right? So you can have people who they apply for a job in data science, they get it, they think it's going to be kind of about one thing, but when they get in there a little more, maybe they realize that maybe it wasn't quite as technologically sophisticated as they thought, right? Maybe the company has them, working in Excel, doing some very basic things, and they labeled this as, data science, but maybe the person getting the job doesn't really think of this as data science. And it can go to the sort of the extreme end, right? If you're someone who's familiar with research and statistics and, maybe some, basic machine learning, and you get into a job where, you're doing more sophisticated, deep learning or that kind of thing, you might feel out of your element. And similarly, with the range of data you might use within a job, right? You get accustomed to using a certain type or format of data. But I've worked with everything from, data from, cloud providers like Google Cloud, all the way to being emailed a text file of data, with no delimiters in there at all. So the data is kind of just all squished in the columns, right? So once you kind of get into this and you start to talk to people who have some different jobs, you realize thinking of things as like a data science job, the variation between jobs can be so dramatic that, it's almost not useful to call it under one title, right? It's almost not useful to just think of it as data science. And so the reason I mention this is just when you're going and looking and applying for data science jobs, to sort of ask these questions about what type of data will I be working with, how do you usually pull that data in to work with it in R or Python, right? What types of methods are you working with? Because, when you apply to a job and it says, you need to use some machine learning, you might be doing some machine learning, but it's also possible that the person who wrote that ad has no idea what machine learning is, and they just want to cover their bases and make sure they get someone who knows how to do that. And you might not be doing that at all, right? So if it's something that's important to you and that's what you think the job is about, you kind of want to make sure there's actually that fit there ahead of time. And that's true, no matter what job you're getting. If it's a software developer, you might think you know what this company means by software development, but when you actually get in there, you might realize they have a very different thing in mind. And you want to make sure there's that fit there between your skills and what interests you and what the company wants. So those are just a couple things that, were sort of on my mind. But yeah, I'm happy to answer questions. And I have an RStudio terminal ready to go to, so we can take a look at some things. So
yeah, for sure. I think we could probably go over some of those data sets that you had, some maybe data sets demonstrations you had prepped up, I guess.
Sure, yeah. I see Gustavo has a question.
Yes, thank you. Can I ask now, or would you prefer to do the demo first?
We can probably wait until the end here, and then we can probably go with the Q&A.
Okay. Okay.
Yeah, so I'll share my screen here. So I don't have anything like, formal planned, but I thought we could kind of just walk through an example of analyzing data, really, I guess, from beginning to end, with the sort of caveat that, we only have, probably half an hour, 40 minutes to do this, but we can quickly jump in here. So, I'll keep things at a broad level. This won't be something that necessarily, every line I type will make perfect sense or anything, unless you're very familiar with R. But the first thing I'll say, because someone asked about it before we kind of officially got kicked off here, is, what IDE is most common, or, for using RStudio. So you can use RStudio, you can use R, the programming language, in just like a terminal. Like if you have a Linux machine or something, you can just use that in the terminal. Most people, I think, use R in an IDE. Even the most popular one is RStudio that we're looking at here. But there are others, although I think RStudio is the most common. The one thing I'll mention too is that you can download that for free if you go to rstudio.com. You can get that for Windows and Linux and Mac and that sort of thing. The other option that's available too is if you go to rstudio.cloud and click Get Started, you can log in with like a Gmail account or something like that, and then you'll have RStudio in the browser. So it'll look exactly like the desktop version, but it'll just be in the cloud. All the work you do will be saved. Things like packages that you install and that sort of thing will be saved in the cloud. And also the computation that you do is on their servers. So if you have, a bit of a slower computer or something like that, you can, do all that computation in the cloud. So as far as, a data set to analyze, I'll maybe just grab one offline. So if there's this great initiative called Tidy Tuesday, and what they do is post a whole bunch of data on GitHub every single week. And it's sort of affiliated with R, but obviously you can analyze the data in Python or whatever you're familiar with. Let's just see here. Let's see what they have for 2020. So there's, a whole bunch of different things. There's different things we could look at here. Let's just see what kind of information we have here. Okay, I mean, this looks pretty good. So they have the data here. You can install this package called Tidy Tuesday, where you can pull this data directly into R. But what I'm going to do, and what you could do if you were wanting to do this in Python or something, you can just grab this raw link to this CSV here, and there's just one CSV here. So what I'm going to do is just open up an R script here. And like I said, with only 20-30 minutes, we'll have to kind of move a little quick, but I'll kind of explain to you, if you're not familiar with R a little bit here. So in R, there's this package, or this set of packages called the Tidyverse, and this package has kind of revolutionized the way people use R. It has a bunch of packages for working with data, from doing everything from like reading in data, all the way to, manipulating strings or working with different categorical variables, as well as things like plotting. So what I'm going to do here is just, I'll just call this data, and I'm going to read in this data set here. So if you're not familiar with R, this little operator here is the assignment operator. So basically the same as just the equal sign in Python. If you do something like read CSV, that will assign it to data. So now we have this object called data. We can see here in the IDE, it kind of gives us some nice options for just looking at the data. So if I click that, I can see the CSV I loaded in. I can see it has, 18 columns, 132,000 rows. And this data was all about, what is it, collegiate sports. Comes from the equity and athletics data analysis, or okay, that's enough to get started here. So we have things like the year, some ID number, the institution name, the state, zip codes, so on and so forth. But there were some things that I thought were kind of interesting in here about, let's see, what was this? Okay, so yeah, this is great. So we have, and I've never looked at this data set before, so this could go horribly wrong very quickly, but we'll try our best, right? So, but we have something here that's the count of the total. I take this to be the total male student population, total female student population, and then we have some columns here about the participation rates of men and women, right? So that, automatically I start wondering about, oh, and that's actually as, okay, those are just counts, not as percentages or anything like that. So this is good. So maybe what we'll do to start is, let's build, some simple summary statistics. So if you're not familiar with this, in R, this is what's called a pipe, and they have pipes in, I believe they have pipes in Python as well. But if you're, familiar with Linux or Unix, the pipe will just take whatever you give it and then pass that to the next function. So we'll see how this is useful in R here quickly, but maybe what I want to do, I'll just look at this data. Maybe what we want to do is, and I'll just do it this way. So I'll select out a couple columns that might be useful here. So I'm going to take in the, what was it? It was EF male count, and I'll take EF female count, and I'll take EF. I don't know what the EF stands for, but maybe figure that out. It doesn't really matter. We'll treat those as just counts, and then I'm going to take those participation for men and women. So here I'm just selecting out the columns that I want, and this just makes things a little easier, so I don't have to struggle and look for all those columns. So here we can, and you know what, I'm also going to include the institution names. Like this is the university or college. Okay, so now we have these, 6 columns here. We have these 130,000 rows, and we see we have, University of Alabama, and then I guess I probably want the year too. Otherwise, this isn't going to be super interpretable. Let me just take a look at here. Something's replicating. Classification. Okay, so there's different codes for like sports and stuff. Does it tell us what those are? Yes, it tells us sports, basketball, and so forth. So I'm going to take sports too. So here now we have, we have different measurements for each year. We have the institution name, we have sports, we have the count of male students, female students, the total count, which is just the sum of this, and then we have the number of participation, or number of men who participated, and the number of women. So the first thing I might want to do is just look to see what the total count of people are divided by, or sorry, the number of male participants divided by the number of total people, and the number of women participants over the number of total people, right? So what this would give us is the proportion of participants that are male versus female. And maybe, another way to actually do this is to, I'll just do this and then I'll quickly explain this. We can take, proportion, let's call this proportion women, and we'll take this divided by EF total count, Or you know what, we'll do this. This, summarize, and we want to do some of this. Yeah, we'll just do something like this. We'll quickly talk about this, and then we'll just make a quick visualization. So that's not right. Let me get rid of this. So here, maybe what we'll do is start this way. So what we've done here, we have data, and again, we'll have to go kind of quick, but what we're doing is we're taking data and we're piping it to this select operator here, and then we're just picking out these columns that we want. So if I run this here, we can see we get these columns here, and then we're taking this new data set and we're piping it to a new function called mutate. And what I'm going to do is take the number of women who participated and divide that by the total number of participating people, right? So in here, there were 31 people, probably 31 men on this basketball team in this particular year. And there were, I'm assuming this means that there was no women, the fact that this is missing. So what I'm going to do is take, whatever this number is and divide it by the sum of these two to get an estimate of the proportion of women who are participating here. So here we see that this is NA, and that's fine. And then here we see that there are, roughly 40% of women make up this particular sport, so basketball in this case, at this particular university. And maybe what I'm going to do to deal with these NAs, I'm going to use a function called replace NA, and I'm just going to say that I want to replace the proportion of women as being 0 if it's missing. So now we have this column here, and we can, do some interesting things with it. So let's make a visualization out of this. So we've sort of cleaned up the data. We've created a new column that has the proportion of women. So in this case, there's 0% of women who participate in baseball. I think I misspoke before and said basketball, but baseball at this Alabama university, right? So now what we could maybe do is, and let's see what year range we're working with here. Maybe we'll just filter. Okay, so maybe 2015 to 2019. But maybe what we'll do here is we'll filter and say, let's only look at something like sports equals. Let's just look at basketball. Now what we've done is we've filtered this. That should be that. So now what we've done is filter this data table down so that we have 10,000 rows now. That's still too many. So let's we'll do another filtering step and say that we want the year to equal 2019 because that was the most recent. That gets us 2,000 rows. I want to make a visualization here. So this is too much. Let's do how else can we separate this down a little bit? Let's look at the original data. I just want to make a nice visualization. Okay, let's take the state ID column too. State. And let's filter. So that we have. Let's just take a look at this. Oh, it wasn't state CL. What was it? State CD. State CD, and let's just filter state CD so that we only have the colleges from Alabama. Let's get us something, 44, that's perfect. So now what we can do, we selected out some columns, we've made a new column that we want to analyze here, the proportion of women. We've replaced some NAs, we filtered it, so we're only going to look at the sport basketball from the year 2019, which is the most recent data, and we have only from Alabama, right? So we can do this in different ways, but now the nice thing about in R and using these pipes is we can just take this data set and we can just feed this right into a plotting function. So if we have, we can use this function called ggplot, and we'll say that on the x-axis what we want is the proportion of women. On the y-axis we're going to have our institution name. Let's see here, no, let me get us to that. Institution name, and then we are going to make basically a scatter plot. So now let's see here what we have. So now we have a plot. It has all of our universities or colleges, the proportion of women, and we have a bunch of points. Now this plot's kind of hard to read because if I want to find the ones with the highest, I got to kind of go and search and then, you know, look across to see which one it was. And, you know, it'd be nice if we could order these from highest to lowest. So what I'm going to do is just put one additional step here is I'm going to mutate this institution name, and I'm just going to change the internal ordering in R. So I'm going to use a function called fct reorder, and it's going to reorder this this factor or this categorical variable according to this variable here. And I'm going to pipe that in. And now when we look at our plot, we see that we have it organized from lowest to highest. So we can see, you know, Faulkner University had, you know, 65% participation rate, and all of these universities have, you know, 0 participation rate of women in their sports programs, at least for basketball, and at least for this most recent year, right? Another thing we could do too is say, well, you know, this was just looking at basketball. What if we want to look at all the sports, right? Well, we could change, you know, this for baseball and do things that way. And now we got a plot for baseball, and we see that, you know, all of them are 0 actually. You know, let's take a look here. What I'm going to do here is just to get a sense of what, or here, I'll use this distinct. It's just going to tell me what sports are in here. So we have basketball, all track, combined, football, golf, soccer, etc. You know, let's try soccer. Here's soccer. Okay, so this one here, there's some that have, you know, 60%, but a lot of them just have 0, right? So we could keep, you know, jumping around and changing this value in here for a whole bunch of different plots. But what might be cool is to make, you know, maybe we don't want to do it for all 38 sports, but maybe we want to do it for like the top 10 sports, right? So let's, here, I'll do this. We use a function called count here. What this is going to do is tell us how many each of these sports occur. And if I use this option here called true, oops, we're going to get, okay, so basketball occurred 10,000 times in the data set, volleyball 9,000, soccer 8,600, and so on. What we'll do here is I'll just make a new little data set called, you know, top 10 sports. And we'll just take the top 10 here. And you know what we'll do? The top dozen. We'll see why this is nice. So now we have, you know, these sports here. We have, you know, basketball, volleyball, etc. So now we can do is we can, rather than filtering for soccer or something like that, let's filter for, you know, our top 12 sports, right? So now if we look here, all we have here is these 12 sports we've identified. So now we've filtered that for 12 different sports. And now we can do something really cool. We can facet this plot, which is just to, you know, make a bunch of subplots. And what we're doing here, this little tilde here just says, all of these plots we made do the same thing, but make every single plot for each sport we have. And that's going to be 12 different sports. So if I, what is that called? It's called sports, not sport. So if I do this, what we're going to get is 12 different plots. On our y-axis, we still have these, you know, different states, and we have our proportion down here. But now we have a subplot for track and field, for baseball, for basketball, for football, and etc. And then we can, you know, use some tricks. I'm just going to load in a package that has this nice function for sort of reordering this. Let's just see. Reorder within, reorder institution name within sports by this. And again, I wish, you know, I wish we had more time together. We could dive into this and talk about it in more detail, but just as a quick demo, I'm just going to change a couple of things here. Let's see, does this work? First try. No. Warnings. What warnings did I get? Institution name, reorder within, arguments is not, blah, 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 blah. I did something wrong. reorder this by, oh, that's why I did this the wrong order. Proportion limit by, does this work? Second tries the charm. There we go. So now we got a plot, right? Now we have a subplot for each of these sports ordered. And, you know, some of this isn't that nice. They're all zeros, right? This looks nicer when it kind of goes down smoothly and continuously. But, you know, maybe we could pick a different state, and maybe we'll get a, something that looks a bit different here. It's nice when you have, what do we have? I don't know what this is, Maine or Michigan or yeah, something like that. Let's see. How does this work? No real different. It's nice when it kind of looks like this. But in any event, I only show this to show, you know, in R how quickly you can do some of these visualizations and data processing and analysis. And, you know, if we had more time, we could look into some other things that are kind of cool too. But, you know, I guess what I'm trying to say is in R, you have a lot of these functions that work really well together in this tidyverse set of packages. And I really like working with these pipes here because what it allows you to do is it prevents you from having to save a whole bunch of intermediate steps. You know, saving a data set and then using that in the next function. And it also saves you from writing a whole bunch of code sort of from inside out, which I find often can be a problem. So, you know, for example, if you have something like, you know, if I just take some numbers, like the range from 1 to 10, and I want to, you know, I want to get the square root of all those numbers. And then after that, I want to, I don't know what, you know, get the mean of those numbers, right? And then I want to, you know, square root that number again for some weird reason, right? You sort of have to look at this and read it from the inside out, right? You have to look at the data, and you have to look at the next function, then the next function, then the next function. Whereas when you use these pipes, the nice thing about it is you can, you know, read it, you know, more like a sentence. You can read it from beginning to end. You see, we get the same number out there. But you can start at the top and say, okay, you know, what data do I have? It's this. And then you can sort of, you know, read this as a sentence from one step to another. And I know, like I said, I'm pretty sure they have these pipes in Python as well. But it provides a very nice sort of linear way for dealing with code. You can sort of, like I said, read it as a sentence from top to bottom, starting with your raw data, you know, filtering it, mutating it, and then plotting it, you know, doing different sort of internal rearrangements of factor levels and that sort of thing. So it's kind of a nice way to work. But maybe I'll stop talking at this point and ask if there's questions. I don't know if that was useful or not. I hope maybe you find it interesting, or you kind of see, if you're not familiar with R, that, you know, it's quite similar to Python. You've got these functions like filter. I know that there's, you know, similar things in, you know, pandas and that sort of thing. But yeah, if you have any questions, let me know. If there's something you'd like to see in particular, let me know as well. But
yeah, this is really exciting seeing you demonstrate using data sets. It's very similar to even SQL too, some of it. I know that some of my friends here are kind of familiar with SQL and Python. I guess we can probably just shoot off a couple of questions here. Gustavo had a quick question about, looks to be, what are the most demanding responsibilities, tools, techniques for data science related jobs? I guess.
Yeah, that's a good question. So I actually, this quote I saw, I'll just quickly read it from a data science book, and I can't remember what data science book it was, and I don't think I read any more of the book than this one quote I saw. But I like this, and this gets to your question. This person says, you know, value doing the simple things right. Data science isn't rocket science. Students and practitioners often get lost in technological space, pursuing the most advanced machine learning methods, the newest open source software libraries, or the glitziest visualization techniques. However, the heart of data science lies in doing the simple things right. analyzing data or understanding the application domain, cleaning and integrating relevant data sources, and presenting your results clearly to others, right? So that kind of gets at the question, right? What are the sort of workhorses in data science, right? And the answer to that is, well, at least for me, right, I think of data science as being, a pyramid, right? And at the bottom of the pyramid, it's not, machine learning, right? It's not deep learning. It's not even visualization. It's not even cleaning data. It's not even reading data. And the first step is understanding data and thinking about data, right? Given some data or given a question, you want to understand something about the world. Well, what data would I collect to do that thing, right? Conceptually, before we even open up R or anything, right? Thinking about data, what sort of inferences can we make from data? What inferences can't we make from the data, right? Can we establish causation from the data we have? Is it going to be correlational, right? What types of things can we do with the data? That's sort of the groundwork. And then you get into things like reading that data into R or Python or having it in SQL or whatever it is, and getting that data into the shape you need, right? So that data manipulation aspect. So every project you do is going to have some data manipulation aspect, whether it's just making a single column like we did that had the proportion of women that were in a particular sport, or whether that's taking a really, really messy Excel document that has a whole bunch of tables spread throughout 20 different tabs, and you need to read that all in so you got one clean data set to work with, right? That you're going to have to do in every project. And then sort of the next layer up on the pyramid is, understanding the data, whether that's summaries, whether that's, a visualization, whatever that is. And again, you're going to do that whether you're going to be doing some deep learning or whether that's where that's where your project ends at a visualization. And then the next layer on is, modeling of some sort, right? Maybe a simple model. I think of, an average as being a model, right? You have a set of numbers. That average tells you what that typical or the representative number is in that whole set of numbers, right? That's a model of sorts. But then there are more advanced models, right? Linear models, right? You're going to model a particular variable like people's happiness as a function of how much money they have, right? So it's, well, how well does that model fit that data, right? That's, one step. And then you can get into more sophisticated models that are either more sophisticated by themselves or maybe you're including more data in there. And then, on top of those statistical models, you have machine learning. You have deep learning as a subset of machine learning. So to me, all of this sort of builds up, and the workhorses are really those things that you need to do in every single project, right? You don't always do deep learning in every project, but you need to read in, manipulate, think about data in every single project you do. And then, the specific tools you use come down to part personal preference, part what, the other people on your team might use. For me, as you kind of know, I favor R, but other people on my team favor Python. And so I think that answered the question. But to me, that's really the way I think about data science, is that you're really, the more boring things, quote unquote, boring things are really at the heart of data science. And it's those other more, fun, neural networks, everyone loves those, but those are things that you apply once you understand the data. It's not just, well, I read in some data, I don't even know if it's read in properly, but now I'm going to start trying to, run a neural network on it, right? It really starts at that slow level of understanding the data, understanding what the relationships are, visualizing the data, and then seeing if that particular technique is applicable to that data. That's how I'd answer that one. Yeah.
Yeah. I honestly, I love it. You're definitely getting really passionate about it too. I can tell. I guess I think Gustavo had a question here. He had more of a question, more leading off to it. You can go ahead and talk, Gustavo.
Thank you. It's just before we jump to the next topic about this. I'm completely agree with you about the soft skills or not technical skills of data science that are required for the data science positions, like the storytelling and the convincing and that kind of thing. So, but I kind of find those skills a bit complicated to prove during an interview. And I don't know how it's in the thinking now in job fishing, like in a job interview. How can I sell myself to get the job? And I know that this is a really important skill, and it's really appreciated. But I don't know if it's a common question in interviews for data scientists in Canada, in Winnipeg, in this case, and if in your previous experience in job interviews with this position, they ask about how could you present the results, or how could you tell the story of the findings, or how could you do this kind of activities of a data scientist, or they are more like, tell me which model of machine learning can you build, or which language are you proficient with, or what are the main priorities of the recruiters finding for data scientists, and how can you sell that you are proficient in this kind of soft skills?
Yeah, that's a good question. Yeah. So the thing I would say, about communication, and like you said, about communication and explaining, maybe how a model works, or what you can gain from a particular plot, or whatever it is, or just communicating results or whatever. There's two things that jump to mind to sort of prove that you can do it. One kind of comes before any sort of interview or anything like that, and that comes back to sort of your your portfolio of work. Right. So if you're going to have a portfolio, right, you've got some projects on GitHub. Part of that, should be that you're describing what it is you did, why you did it, what the results are, what we took away from that. Right. So if you got a project that you did a data analysis and it's on your GitHub, I would say have a README that has again what you did, why you did it, what the results mean, and etc. So that when someone sees your application and they see, your GitHub link and they go to it, right, they don't just see a mess of code that you've written that you might have copied from the internet that you don't know what it means, but they can see, okay, wow, he's explaining exactly what he did here. He's very clear, right? And he's right? He explained what you see in this plot. He explained what's interesting about it, and he even had a good insight here, about this one plot, about why that might be, right? So as me, hiring someone, I look at that and I say, okay, this guy knows what he's talking about, right? I shouldn't say guy, this person knows what they're talking about. They can clearly, explain themselves, in a sort of written work like this. And that's important for all communication. And then the second part of it, that would be, part of the job interview, I guess it comes down to two things. Often, there's a technical component to these positions where you'll get a data set to analyze, or you'll get some questions or whatever. And again, typically it's not just a matter of running the code to get the result, but you need to explain what you did and why you did, right? So if you're a technical whiz, but you botch the explanation for what this t-test is doing, right? That's not going to reflect great. And same thing if you can generate the plot and everything like that and clean the data, but then you misexplain what the plot's actually showing, or it's just a big long rambling explanation with no focus, right? Again, that's not good. So that's something to practice, right? Whether you want to be a physician, or a data scientist, or a software developer, or a furniture builder, or whatever it is, communication is an important part. You're going to have a boss. You're going to need to explain to your boss, what it is you're up to, why you want to do things the way that you think is best. And if you can't articulate yourself and explain this, right, you're going to have a hard time in your career. And if you can stand in front of a group of people, or explain to people clearly why a particular method is appropriate, or what it is you see in this plot, you'll go a long way. So I would say those are some of the ways that you can kind of prove that you can talk about these things. Another just quick thing is to give presentations. Right? If you had a presentation of yourself and you put it on YouTube, and you could direct them to it, the recruiters, they can watch you give this 20-minute presentation and say, okay, this person, they were talking about how to build a scatter plot in R, and it was actually really clear, right? Like I could follow along, and I could do that, right? One of the things I did to prove kind of a lot of different aspects there, communication being one, is I did workshops. So I'm doing them for the government now, but I did them back when I was a full-time student at the U of M. And again, right, if you do an R workshop, for example, you're basically proving that you know how to program in R, is an example, right? It's fine to say, well, I attended a workshop, but it's not super convincing that you actually know how to program in R. Whereas if you present on a workshop, unless you're just messing with everyone and you don't actually know how to do it, people are going to look at that and say, wow, okay, this person gave an R workshop or a Python workshop or a broad overview to modeling or statistics or machine learning or whatever it is, and at that point it's really strong evidence and proof that you're competent in this domain and you can talk about it.
Yeah, that's great. I think I've actually held some BBA workshops for this college club while I've been here attending college, and yeah, definitely just trying to do those workshops, and I'll probably encourage the future leadership to actually do more workshops in the future on campus in our beautiful campus. We had one more question from Romel. How much practice did you do to get the hang of R? I know that data science is a fairly new field in general. I'm guessing, how long have you been practicing and getting used to it?
Yeah, so I got introduced to R in the third year of my undergraduate degree. My beard was a lot shorter then, so that gives you some indication of how long ago that was. So that was probably 7 years ago or so, and I practice every day, I guess, is to answer the question, right? It's something that you can never, whether it's Python or C or R or carpentry, whatever it is, right? You can never practice enough or know enough. So I find myself learning things every day. But to get the bulk of what you need to know in R, I would say doesn't take very long. And I would recommend the book R for Data Science in that domain. If you can get through that book and understand most of what's in it, and get your fingers comfortable to typing out what you need to do to filter data, make plots, and this and that, you'll be 90% of your way there, maybe more. So yeah, I mean, practicing is something that I do all the time, and I'm always thinking about, well, how would I do this in R? And when I can't figure it out, it really bugs me, and I sit there and practice as much as I can to understand how to do that for the next time. So I would say practice as much as you can, and you'll struggle a lot, but you'll learn all along the way. And eventually you just make every mistake you can possibly make, and then there's no more mistakes left to make, and then you know a lot.
Yeah, that's awesome. I think Romel also had that question too about books. Do you have any other websites you have recommended?
Yeah, for I guess it depends what you're interested in, but R generally, I would say R for Data Science is a great book that will get you a long ways the way there. I can recommend on YouTube for sort of watching people program in R, which always isn't it's not always step-by-step explanation, but it's just a good demonstration to see how people are using R. You kind of pick up on some new tricks. I would recommend the data scientist David Robinson. If you just Google his or YouTube his name, you'll see he has a whole bunch of screencasts, and also the data scientist Julia Silge, Silge. She's great as well. Does a lot of machine learning work and works for Rstudio as well, developing packages for machine learning. And then just general stats and that. I like watching YouTube videos as much as the next person. So I like a channel called StatQuest, who he talks about everything from basic correlations all the way up to how do you understand a neural network. So those are some resources, but if there was more specific topics, I could rattle off other books and resources. But yeah, in general, those are the ones that come to mind.
Awesome. I'm guessing I'm trying to encourage some of these guys to start side learning while they're still in school, and having those good habits. I guess Gustavo had another question about how does R perform with a large amount of data, and how easy is it to build a machine learning model in R and deploy it in the cloud?
Mm-hmm. Yeah, those are good questions. So I guess it depends how much you mean with large data sets, but there are packages in R that you can connect to Now, I don't have a lot of experience with this, but techniques like, or methods like Spark for dealing with big data. So there's these tools available for, dealing with big data so that you can have that read into R and work with it. I don't have much experience with working those, so I can't say for sure. But definitely it can work with, quite large data sets, and then if you need those extended tools, you can do that. As far as machine learning goes in R, I think there's a set of packages in R called tidy models, and that is a tremendous package for doing machine learning really from beginning to end. And as far as how long that would take, it's not very much code. It's at a very high level, the code, so you're not, writing functions to do cross-validation yourself or anything like that, right? They have all these functions in there for you. And really, I mean, without getting into it too much, but the hard part about machine learning, I find, is not finding a package or a function that can run a neural network or run a random forest. The hard part is all the pre-processing and the setting up, right? How do you split your data and process that data in a way that's not causing problems down the road that you're not aware of? And that's where I think the tidy model set of packages really comes into its own. It offers a set of functions for doing pre-processing on your training data in the right way, and then training a model, and then applying those same pre-processing steps to the testing data so that you're not, in short, doing things the wrong way. So it kind of helps you along the way. So I would recommend that. And there's a book called, what is it called? I think it's just called Tidy Models with R. And that goes through, from beginning to end, how to use this set of packages. And, very similar to something like scikit-learn in Python or something like that. I'm biased, so I think it's even better than that, but we'll leave that argument for another day. And then, yeah, I think the book is tidymodelswithr.org. It's TMWR.org, tidymodelswithr.org, and that has the code and stuff to get started there. So I would recommend that. But that's a great set of packages for machine learning. Yeah.
We had one more question from Don, and then we can go off to Gustavo here. What's the most impressive visualization that you've built?
Most impressive. Most impressive. I mean, I guess it depends what you mean by impressive, right? There's like the flashy visualizations, right? There's you can do things in R where you kind of make a visualization, and then if you have, say, something that evolves through time, that plot will change throughout time or something like that. And those are cool to look at, right? Again, impressive can mean different things. So, impressive in sort of clarity, right? That can be one way that something can be impressive, and that you take a lot of data that's too much to understand, and you manage to sort of boil it down to a simple visualization that got to the heart of the thing you're interested in. One of the things I like that I think is impressive is sort of visualizing machine learning models. So visualizing, I guess without getting into it too much, visualizing sort of the decision boundaries of things like artificial neural networks and that sort of thing can be really interesting to look at, as well as looking at visualizing the, like the hidden layers of an artificial neural network to see what features it's picking up on or that sort of thing. So I would think that those are sort of impressive things. I mean, another thing that's really fun in R is, making things like interactive maps and that sort of thing. So there's a package, well, it's a JavaScript library called Leaflet, and R has a package for that. So, in 2 lines of code, you can, make your like Google Map type thing and have all your points on there. When you click on the points, it, opens up an image or does whatever. Those things I think are kind of impressive and flashy. But, as far as impressiveness goes, I'd say it depends how you define it. But, yeah, lots of different plots that visualizations I've made over the years that, I was impressed with. Whether anyone else was, I guess, is up for debate. But yeah, it's an interesting question.
Yeah, we can go with Gustavo here real quick, and then we can probably close off with the closing remarks. You can go ahead, Gustavo.
Yes. First, I think in one of my first questions you skip it. Can I ask it now?
Yeah.
Yeah. I really like the transition you made between psychology and to data scientists. And as I was mentioning, and you were mentioning before, one of the most important part is the communication and the storytelling and how to persuade the stakeholders and the decision makers to follow a strategy, that kind of thing. Do you have any tips or something from the psychology area that you can share with us, like how to persuade the audience to follow your path, how to engage better, how to convince?
Yeah, I mean, I guess there's different things that I could say there. So one, in a way, thinking about data and things like that is an unnatural way to think, right? When, if I want to know what car to buy next and someone says to me, well, I had a Camry and that thing lasted 20 years and I never changed the oil and, I never washed it and that thing lasted 20 years and I never spent a dime on maintenance. That's pretty convincing, right? That's a story that convinces us because it's one single example, but it's very convincing, right? It's just like if someone says, well, no, I had this car and, from the day I bought it, I was putting in thousands of dollars a month to keep that thing running. I'm going to think to myself, yikes, I don't want to buy that car, right? But that's not a scientific or data-driven way to think about what car to get. The thing to do is to go online, look at consumer reports, see how much maintenance people spend on these different cars. But that's not the way our brains work, right? Our brains think more in terms of single examples, right? If I know someone who has gotten a COVID vaccine and they got sick off it, that's going to scare me straight. I'm not going to go and look at all the data. So that is one tip, I guess, you could use, in that you can present the data, but then you can also present, very clear examples of a single instance that highlights your point, right? And it's not something that goes against what the data shows, but it's an example from the data that's very clear, right? So maybe, with this example with the sports and the proportion of women there, maybe you could find an example, you could display all the data and everything, display these plots to show the general trend, but then to make your point, you could really show examples from one particular university that has all no participation from women or something like that. So that's one way to do it. And the other way kind of fits into your question about communication, and that is just to be clear. And that takes a lot of practice in describing to people what you did and why you did it and what the results tell you. But as someone who, like yourself, who's familiar with data and these methods, it's easy to take them for granted, and it's easy for us as data people to take these methods for granted, and for us, it's obvious why we would use linear regression, right? It's obvious what it means that the slope was negative 2.5 for this particular variable, right? To us, it's obvious, but when you're explaining these things, you need to remember that people don't have these sort of same experiences, and if you're a stakeholder and you don't have statistical background, all of this is going to be not helpful. So you have to sort of try to understand where people are coming from their background, what their interests are, so that you can explain things to people in a way that's useful to them. And as far as being clear goes, I guess it's something you just practice over time. And I would again recommend practicing it, whether that's in blog posts or a presentation, or see if you can explain to your your roommate or your mom or your grandma or whatever, well, how does linear regression work, right? And you should be able to do it in a way that they can appreciate and understand, and they can see the motivation behind it, and they can see the importance of doing that thing. And if you can do that and think in those high-level ways, then when it comes time to explain it, you'll probably do a better job. And you always have the mathematics in your back pocket too if you need it. But being able to explain things the way you would to a 5-year-old is good practice too. Yeah.
Nice, thanks. Yeah, I have some more.
I gotta close it off here because I have a class in like two-ish minutes. But I'll Yeah, we answered a lot of questions here. I'm guessing as one public servant to another, I want to thank you for coming by and stopping by, Matthew. It's good to give back to the community and the upcoming industry, I would say. Um, and yeah, just thanks for stopping by. The Bits and
Yeah,
Bytes
thanks for having
Association.
me.
It's a good honor to see you and actually talk to you via um, MS Teams, I guess. But yeah, I'll link off the rest of the recordings. I know he had some of the iPad videos that I'll probably just send off in our Discord server, and whoever's here will be entered for a gift card. So look out for that. Yeah, I'll thanks for stopping by, guys, and I'll talk to you guys in the dark side, I guess. I don't know.
Yeah, thanks everyone. Yeah,
Okay.
appreciate it.
Take it easy,
Thank
guys.
you.
Matthew, are you in LinkedIn?
No, not on LinkedIn actually. No.
Okay. It's okay.
Oh darn! I was gonna try to find you and connect with you.
Yeah, you can always